Hey everybody, Ms. Dupree here. Today we are going to learn about the importance of gravity in our solar system. In our Force and Motion unit, we learned that gravity is a pulling force that pulls one object toward another object. In this lesson, we will learn about the role that gravity plays in our solar system. We will learn why most objects in the solar system orbit the Sun, but why some objects, like moons, orbit planets instead of the Sun. Let's start with an understanding of how gravity works. Most of you know that Earth's gravity is what keeps us pulled down to the ground instead of floating around. Obviously, Earth has gravity. But did you know that everything has gravity? That's right, all matter has gravity. Even you have gravity. So why aren't you pulling things to you? Well, it's important to know the two things that tell you what pulls one object to another object. The force of gravity depends on two factors, mass and distance. Let's start with mass. Remember that mass is how much matter is inside of something. Objects with more mass are heavier than objects with less mass. Gravity is related to mass. The more mass something has, the more gravity it will have. Less mass means less gravity. So the reason the Earth's gravity pulls everything on it is because Earth is so much more massive than all the objects on Earth. So Earth's gravity is stronger. In our solar system, the Sun is by far the most massive object. In fact, the Sun contains 98% of all the mass in the solar system. Did you know that the Sun is so huge you could fit 1 million Earths inside of it? That's pretty massive. Because the Sun is so huge and massive, its gravity is much, much stronger than all of the other objects in the solar system. So the Sun pulls the planets, comets, asteroids, and meteors towards it. If the Sun is pulling the objects toward it, why don't the objects get pulled into the Sun? Think of it this way. Remember we learned about balanced forces, where all the forces are the same. Well, the planets are actually trying to move in a straight line with a lot of force. But the Sun's gravity is pulling back on the planets with exactly the same amount of force, so the forces are balanced. Instead of traveling in a straight line, the Sun's gravity catches the planets and makes them move in a circle around the Sun. This is called an orbit. An orbit is also called a planet year because each planet's year is the amount of time it takes to make one complete orbit around the Sun. All of the planets have different orbits depending on their distance from the Sun. The closer to the Sun a planet is, the smaller its orbit is because it makes a smaller circle. So Mercury, the closest planet to the Sun, has the smallest orbit. It only takes Mercury 88 Earth days to orbit the Sun one time. So 1 year on Mercury is only 88 Earth days long. Which planet has the longest orbit? Well, that would be the planet furthest from the Sun. If you said Neptune, you're absolutely right. Neptune's orbit, its circle around the Sun, is so long that one Neptunian year, one orbit, takes 165 Earth years. That's a really long time. Remember, it's the Sun's huge gravity that keeps the planets moving in an orbit around it. This is why the Sun is called the center of our solar system. It's in the center, and everything moves around it. If the Sun were to suddenly disappear, what do you think would happen? Well, the gravity that is forcing the planets into orbit would also disappear, so each planet would instead shoot off into outer space in the straight line of the planet's force. So remember, the more mass of the object, the more gravity. The Sun is the most massive object, so most things in the solar system orbit the Sun. But there is an exception, moons. Moons do not orbit the Sun, they orbit planets. Earth has one moon that orbits around Earth. Jupiter has many moons that orbit Jupiter. Why is this? To understand why moons orbit planets, you have to know the other factor that determines the pull of gravity. That factor is distance. The closer that two objects are to each other, the stronger the gravitational pull between them. Look at the diagram. The two objects on the top are closer together, so the pull of gravity is stronger. The objects on the bottom are further apart, so they have less gravitational pull between them. Make sense? Earth's moon is much, much, much closer to Earth than the sun. So even though the sun's actual gravity is much stronger, Earth is able to capture the moon with Earth's gravity because the moon is so close. It's the same way with other moons. Jupiter has at least 63 moons, and they all orbit Jupiter. This is because they are close enough to Jupiter to get caught in Jupiter's gravitational pull instead of the sun, which is much further away. So what would happen if a planet disappeared? The moons of that planet would stop orbiting the planet, and guess what they would orbit instead? That's right, they would start orbiting the sun, because they would get caught in the sun's gravitational pull. Okay, let's review. The pull of gravity depends on two things, mass and distance. The more mass an object has, the stronger its gravity will be. The sun is the most massive object in the solar system, so its gravity is much stronger than anything else. So most things are pulled in a circle around the sun. This is called an orbit. But the closer that two objects are, the stronger the pull of gravity between them. Moons are very close to their planets. Because they are so close, they get caught in their planet's gravitational pull. So that's why moons orbit planets. Please pause the video now and copy this flow map into your notebook. If you have any questions, please ask your teacher. Good job, everybody.